Thank you all coming for my session. I really appreciate for you taking the time to attend this session. I know there's other parallel tracks happening, and I really don't take it for granted. So my name is Hungai Amuhinda, and I'm here to talk about distributed tracing. So just about me, who I am. I'm originally from Nairobi, Kenya. That's where I'm based. So thank you to Alex and the team for making it happen. I work on infrastructure at a company called Azure. Azure is basically a customer analytics company, and I've spent maybe 2 or 3 years building data pipelines and monitoring or just observing data pipelines. So this is basically a very introductory talk. We'll have some code snippets at the end and some demos. But if anyone is really experienced or running distributed tracing, I don't think you'll benefit much out of this talk. But for anyone who's here for introductory material, this is perfect for you. And if you're here and you decide to stay and you experience, please hold me accountable if I say anything that is a lie, and just feel free to shout out. Right? Cool? Okay, so at the end of this talk, I just hope that, you're able to pick up 1 or 2 things that you can take back to your company or your team and incorporate that into whatever you're doing. And how I want you to use this talk is just don't take everything literal. Don't just blindly follow. None of software is like that. And software is about trade-off. So it's just about preference. There's things I might talk about here that you probably wouldn't do, and there's things that you might want to talk about that I probably wouldn't do. So, and there's lots of ways of doing things. So what I would encourage you is to try this within your team, and because you probably know most of the context within your team, you understand the domain, and trying out things would probably be more helpful than blindly following what I'm trying to say. Okay. With that being said, let's get started. So just a bit of history. The last maybe decade, we've spent, building monolithic applications. And we've witnessed a change and shift on how we do that, or how we deployed internet scale applications over the last few years. So historically, we did, it was a single process implemented as a single runtime. Deployment was just, single language, probably lump stack most of the time. And it was great for quite a while, right? It was easy, straight up. But then scaling monoliths was becoming increasingly hard as we go. It became tedious and painful. One reason, as teams grow, most of it, a big team contributing to one single repository, changes basically it's a pain, right? Deployments are all or nothing. A deployment is basically a day where you just turn off everything so that we can deploy that, right? So this is really painful. And the industry started moving away from deploying applications as monoliths to microservices because of either scaling organizations or scaling teams, or so we moved into this other architecture, so distributed systems. And this was really pushed by container technologies and cloud computing, and now you can easily deploy services to multiple clouds. You can do on-prem and on cloud at the same time. Teams can be using tools that they actually enjoy doing. So a data science team would write a recommendation engine in Python or Scala, and another team would write maybe an API gateway with Node. So teams get to use what they actually enjoy and what would be the best tool for the job. And by adopting microservices, organizations are reaping a lot of benefits, from better scalability of components to higher developer productivity. But despite the benefits and eager adoption from companies large and small, microservices come with their own challenges and complexities. So an example would be, so suppose we have 20 components in in an application, and all of them are required to produce a response on a single request. When we run in a monolith, our failure modes are restricted to bugs, potential crashes, and you can basically just use logging to get an idea of what's happening. But if you run the same components as microservices on different hosts separated by networks, we introduce many more potential failure points, from network hiccups to resource constraints, right? So observing such a system drastically reduces if we try to use traditional monitoring tools. So this is, metrics and logs, because you can only, so with microservices, new challenges are introduced. And it's a trade-off for one set of organizational and technology problems for others. Now you have to think about deployment, packaging, and configuration management to debugging and secret management. But in this talk, we're just going to focus on a small bit of observability, which is tracing, right? Okay. So it is much harder for teams to understand exactly what happened when you're using distributed systems, because a single request tends to go through multiple servers before it's being served back. And while the benefits of that, clear organizational boundaries, a division of labor, greater agility, there's a lot of costs that come with that, right? And traditional monitoring tools are very ill-equipped in trying to observe that. They might tell a story from a single instance, but again, a request will touch multiple servers before serving the request or responding back to the request, and a single instance is not enough to give you context of what's happening. And in a monolith, troubleshooting that would just isolate an instance, reproduce a problem, and you're good to go, right? And with microservices, this approach is no longer feasible because no single service provides a complete picture of the performance and how the application is supposed to be, working. And that's where distributed tracing comes into play. So what is distributed tracing? Distributed tracing is about understanding the path of data as it propagates through components in our application. In a nutshell, the tracing infrastructure attaches contextual metadata to each request and ensures that the metadata is passed around during the request execution, right? And capturing these traces allows you to build the view of an entire chain of calls behind the user interaction. And that simple technique allows a tracing infrastructure to reconstruct the whole path of a request from when the request hits the server to actually getting back a response. So that's the basically how distributed tracing works, right? And in order for us to discuss the core concepts of how distributed tracing works, we need to define some common nomenclature that and explain the anatomy of a trace. So a trace follows a request of a system event from its source to the ultimate destination. And if you're hitting 20 microservices and each service is generating a span, combination of all those spans is what we call a trace. And each trace is a narrative that tells the story of a request as it travels through the system. Next, we want to look at what's inside a trace, which is a span. And a span is the primary component within, represents an individual unit of work done in a distributed system. Spans are generally named and have a start time and an end time. I don't know if I captured that. Oh, no, I didn't. And each span is tagged both with a unique ID as well as the ID of the trace and the ID of the parent span. And all this correlation data is propagated downstream and reported out of bound to a distributed engine. So most of the available distributed tracing engines, I think, use UDP to report the data out of bound. So this does not affect your application at all. And this feature of distributed tracing makes it possible to correlate data across processes together and figure out exactly where something went wrong. Yeah, and at the top, span A is what we call the root span. It's the first span in the trace, and usually the duration is approximately how long the trace took to go through from the first time it hits the server to when you get a response. Next, we have context propagation. Now, distributed tracing wouldn't work without context propagation, and context propagation is basically, or tracing doesn't work without context propagation. Typically, because a distributed trace traverses more than one service uniquely, and passes information from one service to the next one. This could be through headers or in other forms. So metadata propagation is probably the most popular way of doing that. There's other ways that have been documented. I think Facebook and Canopy do it differently, but metadata propagation is probably the most common. Yeah. So so the data is carried alongside the business request as part of the headers that move from. In this example, it would be when the first time the request hits our service, we first extract the headers and check for trace ID, the parent ID, and the span ID. Trace ID and the span ID if they're available. And if another service had sent this request with this information, then it will just be a continuous trace. But if it's the first time, then we have to generate this information if it's not available, right? So we try extract the headers. If we don't find any trace headers, then we generate a trace ID, a span ID, and a parent ID. Since this is basically the root span, if we manage to get trace headers, then the incoming requests we would extract the trace ID, parent ID, and any other baggage information that we might want to propagate downstream. And when we send this information to the next service, notice that the parent ID now has an ID that was the span ID in the first service. And now the other service has a new span ID, which is different compared to the first one. But the trace ID remains the same. And this is how we're able to get that directed acyclic graph, because we're able to correlate this information and how it flows from this is the parent, that's the child, or follows through. Okay, so next we have tags and logs. Both of these, they annotate a span with some contextual information. Tags would typically apply to the whole span, while logs represent some events that happen during the span execution, right? So, and something to keep in mind, tracing infrastructure does not track causality between logged events the way it keeps track of causality between spans. The relationships can always be inferred from the timestamp in logs. Now, you're probably asking, so what can tracing help me answer, right? The first question that we found that was very interesting was, what services did our requests pass through? This sounds like a very trivial question, but if you think about it, let's say from an organizational perspective, right? You hire new developers, you have about 200 microservices, and the mental model of how a request goes through the system, it's much, much harder to try and explain than when it's just 5 services, because with 5 services, you can just say like, yeah, this is how a request will go through. With 200 or 10x that, then the mental model in your head, it becomes even harder and harder. But with distributed tracing, it's much, much easier to try and explain that, because you can actually use the visual aspect of the distributed trace to follow through on how the request goes through the system. Second question is, what occurred in each service for a given request, right? When doing distributed tracing, we're collecting like highly contextualized information, and we present this in traces, and we allow we can be able to see what happened within each and every service. We can log errors, we can attach logs. And if one service has, or you can be able to use this to either debug or find out services that are blocking or services that are in your critical path that you need to assign resources. You can do root cause analysis with this type of information too, right? The next one is where did the error happen in the call chain? So if you've been on call, most of the time there's a service downstream that is the one misbehaving, but people up the chain are still being paged. And it's not a good feeling because it's probably someone else's team's responsibility to take care of that. Right? With distributed tracing, we can be able to pinpoint which service down the call chain is actually responsible for that. Yeah. And traces bottlenecks. So I think I've already talked about bottlenecks. And yes, assigning resources or when a service is on a critical path, you can easily see that on the visualization or the UI. And if you need to assign more resources to that, you can be able to do that. And lastly, who should be paged? In an ideal world, different teams would be responsible for different services, and we need to be able to ping the right team when their attention is needed on something, right? No one wants to be paged when they're having dinner with their family. Okay, so if tracing is so good, why isn't everyone using it? I think there's still not enough content out there in terms of education or just published case studies on the benefits of tracing. I'm not trying to diminish the efforts of companies like Honeycomb and Lightstep who've done so much tremendous work in trying to educate users, but I think there's still more that can be done, and there's still room for improvement on teaching and publishing case studies on the benefits of this. The next thing is, for a very long time, most companies and APMs had their own implementations of distributed tracing. So once you bought into someone's solution, you were kind of stuck with what they were doing with distributed tracing. So this was a factor that affected adoption, or it still affects adoption at the moment, but it's getting better and better, right? Piggyback on that is with different implementations, that means that there's a lot of inconsistent APIs. If this service provider A is expensive and you'd like to switch to service provider B, then you have to re-instrument your application again because the APIs are probably different, and that was also a hindrance in this. Lastly is handoffs. This is if service provider A has implementation and is trying to, there's another service downstream that uses service provider B, which is quite actually very common in different teams using different providers but work at the same company. So there's a lot of issues with inconsistencies and handing over the trace data to the next service, right? Now, there's some work that is already happening to try and solve this, and one of the efforts is happening in a product called, or an API called OpenTelemetry. So what is OpenTelemetry? OpenTelemetry is a vendor-neutral API for instrumenting distributed system. It's a collective effort from multiple organizations to standardize on how to do distributed tracing and enable everyone to play nice with each other. Yeah. And it's a single set of APIs for tracing. They standardized on APIs for, context propagation, exporters to your backend of your choice. If you're already using some provider as a backend, you can still continue doing that. And OpenTelemetry combines metrics and traces. I think down the line they might do logs, and it has integrations with the most popular web and RPC frameworks that everyone uses, right? So where did OpenTelemetry come from, right? It's a result of trying to merge two projects that individually were essentially doing the same thing, Open Tracing and Open Sensors. Open tracing was it's under the Cloud Native Foundation, and Open Sensors was open sourced by Google, and Open Sensors provides both metrics and tracing, while Open Tracing just provides a tracing API. But the tracing features for both aim to provide a consistent way to trace across different systems and languages, right? So the goals of merging the project were basically to create a single instrumentation standard and maintain functionality without including every feature from both projects. As loosely, there's going to be a backwards compatibility to anyone who's still using Open Tracing or Open Telemetry for a while. So it's nothing to worry about if you're already using either of the two, right? Now, how do you do instrumentation with OpenTelemetry at the moment? There's two ways. One, using an agent, which is probably my preferred way, and two, manually instrumenting your application, right? With using an agent, I'd give an example. If you're running on the JVM, you attach an agent when you instantiate your application to your jar, and it does bytecode manipulation. It does a bytecode instrumentation and sends this information to a particular tracer, right? With the manual way, you get a dependency for the particular tracer or the particular API that you'd like to use, and then you manually instrument the specific functions that you want to collect information for, or and that could be a bit tedious, and it's the back and forth between maybe ops guys and developers could be, maybe developers don't want to, I don't know, could be harder than just attaching an agent and collecting that information, right? So how to get involved in OpenTelemetry? One, I think there's maybe 7 languages that have been implemented so far, but the best place is to check the GitHub link. And my favorite is OpenTelemetry Tuesday. So if you'd like to just catch up on what happened during the week, OpenTelemetry Tuesday by Liz and Isobel is probably the best place to just catch up easily on that, right? So yeah, if you're a busy person and you'd like, yeah, just shout out to them. So the project is still very young, and there's still a lot that can be done. Please join the mailing list. Please, use the already existing SDKs and APIs to provide feedback to the team that is working on it so that they can improve on it. Now, I'd like to show a demo of how you can instrument an application. So this is an example application with 2 services. There's an order service and an item service. Both services have separate Redis instances as their primary data store, and when an order gets placed, the order service contacts the item service to check if the items requested are in stock or not. And we want to instrument this application. I'll be using Open Tracing instead of OpenTelemetry, but you can use either, right? So the first step is to instantiate a tracer or create a tracer. If you look at line 128, I create a tracer. I have a utility function that does that for me. It basically just creates instantiates and returns an instance of Jaeger that samples 100% of the traces. You're probably wondering, what does a tracer do? A tracer is responsible for tracking a tracer creates spans, gets a currently active span. This is what would extract the span from a header when a request comes in, and would check whether there's already an existing span or not. And the utility function is just returns an instance of a tracer. Now, you don't have to use Jaeger. There's all these different traces and probably more that I'm forgetting that you can use or already using within your company. If you're looking for something that is hosted, Honeycomb and Lightstep and Datadog, New Relic, or they're probably a good place to look at. If you're looking for something open source, there's Jaeger, Zipkin, Apache Sky working, and many others that would come after OpenTelemetry becomes stable. And so I'm using Golang as the language to just show the examples. But yeah, since we'll be, there's going to be a lot of functionality that is repeated, so I just abstracted this to a middleware that would track every request that comes into the system. And yeah, so at line 45, when a request comes into the system, we first check the headers to see if there's any trace-related headers that came in with the request. If we don't get a request, then if we don't get the trace headers, then we create headers and inject that into the context. Now, this is going to be used when we start instrumenting our handlers. For instance, the get item handler in line 207, the opentracing.startSpan from context. So it returns a span with an operation name using any span found within the context that we've passed in as a child of, or yeah, as a parent, yeah. And I'm using Jaeger, and any information about Jaeger, it's a distributed tracing platform, inspired by DAPA and OpenZipkin. It was created in 2015 and donated to the Cloud Native Foundation. It's compliant with both open tracing and open sensors, support multiple storage, and it's compatible with Kafka if you're doing a lot of, because you could end up generating a lot of traces and you'd need some sort of back pressure management. Kafka would probably be perfect for that. All right, so let me just switch to the example. So this is what the Jaeger UI looks like. The application is already running at the back, and you can be able to, from this drop-down, be able to get all the different services that are running. You can look at individual operations if you want, and click on Find Traces. So probably nothing with that. Just one moment. So this is an example of how a trace would look like. This is the root span, gives you an idea of how long the trace took and the methods that were called or the services that the Nini went through. I'll try. Same thing, because the order is much more interesting. So the root span would tell you how long the request took. If you click on a span, you can be able to get more information on what happened, the processes and details that you could use for resource assigning resources to stuff. Let's see if I can get the. There we go. So, yeah. Like I mentioned, this is how we create the tracer. Sorry about that. Yeah. And the tracer middleware and the utility function to just help create Jaeger, return an instance of the tracer. When we go to, nope. Yeah. And then you can attach the middleware to trace each and every incoming request. So, and how to, I guess, just deploy that. I have a simple YAML that puts everything together and just do a Docker compose up, and that's it. So I'll open the floor up for questions in case anyone has questions. Yeah. Thank you for your time. Go ahead.
Just a quick question. If tracing was something I wanted to see grow in my own organization, is that something that one person can start adding into a project, or do you need to get more developers to all start working?
So I think you can start as one person and then use that opportunity to sell to the rest of the team on the benefits of doing that. Because I think going to the rest of the team might be an uphill battle, without any evidence of the benefits of it, it might be a hard sell to that, right? Yeah.
So for open tracing, since it was relatively new that they weren't generating that capabilities, do you think it's mature enough to be used inside of a larger existing application, like a very large application that has multiple services, or is it still kind of an inflection?
So the API might change.
Okay.
I don't know how best to answer that question, but if you're okay with API changing because you'll maybe have to recompile and reinstrument every other time you pull in a new dependency, then that's fine. You can use it.
Thank you.
Yeah. Yeah.
Do you have a cool use case for tracing, say, the name?
There's many. I don't know where to begin. Yeah, we can talk. Yeah. The back.
Do you have any good strategies for how to relate traces together when the operation happens over a long period of time? So I'm thinking about like asynchronous queue worker type workflows where the request will last a few seconds, but like an hour later something related will happen.
Yeah, so I think that ties to sampling because based on how you sample traces, some people might just want to keep one trace out of 100 because they essentially look the same. But there's solutions that can do 100% store all the traces, and you can be able to get insights after a couple of days or weeks if you'd like. And this is probably you can configure traces such as Jaeger to sample 100% or to sample at 1% if you'd like. I don't know if I'm answering the question.
I guess what I'm asking is like, if you've got like one action happens now and then a few related actions happen much later, would you make those part of the same trace or would you have different traces?
If it's in the same service, yeah, it's the same trace. Yeah.
Is there anything in the standards about connecting like a front-end JavaScript application that makes a request on the client to the rest of the trace?
Yes, I think there's efforts in putting together a JavaScript tracing library that you can start generating requests from the front end going back to the server. So yeah, it's possible. Yeah.
Is there any guidance you might have on the overhead involved in this? It seems like if they're gathering information and passing it downstream, we're obviously using more network. If I have to hold it while I'm doing work, I'm going to consume more memory. I mean, how much should I guess I'm going to give up in order to add tracing?
So that highly depends on what you really want to instrument. If you're collecting too much traces, then you might see the overhead, you might notice that there is some performance issues with the amount of data you're collecting. There's probably better ways, or you want to find the functions or places you really want to trace, and then start with that. And then probably with time, you can keep on adding if you feel like you need more visibility into what's happening. Like, okay.
If you have a large call graph, how do you make sure that every player forwards the context? Another way to raise this question is if you're a structure provider, how do you automatically forward the context?
Pardon? Can you just speak out loudly?
When you have a large call graph, how do you make sure that every service in that call graph forwards the context? Otherwise, the context will be lost in the middle.
So that's a very good question. So the question is about context propagation to if you're going through multiple services, right? Yeah. So you might lose context if all the services don't buy into the idea, and it's still, so you need to, one, get everyone who's involved in all the different services to buy into the idea for that to particularly happen. So I really have no idea how best to answer that if not everyone buys into the idea. Because you might have places in the call graph where there is literally nothing for correlation. Yeah.
What is the name of this product?
Name of?
The tracing product?
Oh, OpenTelemetry. Yes. Just if I figure out how to use this thing. Yeah. Any other questions?
The tracing you showed us tended to kind of use the process boundary for an individual trace, but it's very common to get tracing information about what's happening inside of a process,
Can you repeat that?
drilling down to like the function level,
Mm-hmm.
or if you're making a database call to block or something like that.
Yeah.
Tracing inside of a service, as well as, as the request goes from one service to another microservice.
So what's the question?
How common is that?
Yeah, it's common. So there's efforts to implement traces for popular RPC frameworks, databases, and so you can get this out of the box from your MySQL instance or Postgres or whatever provider, and I think the traces will be correlated, or there'll be a lot of causality, so you can be able to do that. Yeah. Okay. Any other questions? All right. Thank you so much, and have a great rest of the day.